So in the last video, we looked at quality, choice, and monopoly, and wasn't too surprising. The monopolist basically maximized profit by setting the marginal revenue of quality equal to the marginal cost of quality. Here we want to extend the model and look at quality, choice, in an oligopoly. So in an oligopoly setting, we have to think about, all right, well, how does my choice of quality affect my demand compared to your choice of quality, right? And so we've kind of already solved this model in chapter 10, where we had quality in the model, but it was exogenous there, right? Firms didn't get to choose it. And so here what we're going to do is we're going to allow firms to choose quality between some level, right? Where the level of quality can range. So quality here is still Z, and it can range from some level ZL to ZH, right? Where ZL is less than ZH. And so we had our consumer demand functions already given by these equations. And just remember, Z here is Z1 minus Z2. So at Z1 being quality, the quality of firm 1, and Z2 being the quality of firm 2. And then the phi parameters were the lower and upper bounds on consumer taste for quality. And what we assumed before, and as we'll see this is important, is that the distribution of quality preferences is evenly distributed. And so that's going to be important because if all consumers prefer higher quality, that's going to be a difference. And if all consumers prefer lower quality, that's going to be a difference in terms where firms produce. So we want to think of this in terms of a dynamic game where there are 3 stages. So in stage 1, firm 1, so they're the sort of leader here, chooses quality. Then firm 2 chooses quality in stage 2, and then they both choose price in stage 3. Now remember, the prices won't be the same because the quality levels are not the same. And so we're looking for the subgame perfect Nash equilibrium, and we need to work backwards. So we know that in stage 3, we've already solved for the pricing for the given levels of quality, right? So we have pricing, we have quantity, we have profits. We just don't know what the quality levels are, right? All we know is the Z parameter, which is Z1 minus Z2. And so we know from before that the price is going to be higher for firm 1 because they have the higher quality product. Remember, Z1 is larger than Z2 by assumption. Quantity is going to be higher for firm 1. And then profits, we're not sure because it all depends really on that fixed cost. And that fixed cost could be related to the level of quality. We kind of leave it open here. We call it a fixed or a quasi-fixed cost. And so that's really going to depend on who earns a higher profit. Does it cost a lot more to produce the higher quality good? Well, then firm 1 might not earn higher profits than firm 2. So moving to stage 2 and firm 2's choice, they're going to choose some level of quality, Z2, looking forward and identifying that Nash equilibrium in the final stage of the game, right? And so they're going to maximize profits with respect to Z2. So now notice that firm 2's profit goes up with Z, right? Both firms' profits go up with Z, but Z equals Z1 minus Z2, right? So that's negative there for Z2. So profit goes down with Z2. That means firm 2's profit will be higher the lower its quality is. And so that means that the firm is going to choose the lowest possible level of quality, which we've assumed is ZL, right? So Z2 star is going to be ZL. And then firm 1 is very similar. Firm 1's profit is saying, all right, well, they're going to choose ZL. And so now I need to choose Z1 in order to maximize my profit. Well, firm 1's profit is rising with Z1. And so they're going to choose the highest level of quality, Z1 star. And so that just means that the, subgame perfect Nash equilibrium is really what we had before, except Z1 star is ZH, the highest level of quality, and Z2 star is ZL, the lowest level of quality. And it's kind of unsatisfying, especially because we only have these fixed costs, and we didn't sort of model the costs of quality the same way we did with the monopolist. And obviously that could have a factor. But the idea here is that basically firms want to be as far away from each other as possible because they don't want to cannibalize each other's sales and compete with each other as much. So this is the principle of maximum differentiation, right? And it follows only because consumer tastes are uniformly distributed and costs are the same. So as we said, if a larger proportion of consumers want high quality, then firm two might produce a higher quality good. And consumer preferences will always be important. And so if quality is a normal good, which we by definition assume it is, then as consumers have higher and higher income, we would expect firms to adjust to produce higher and higher quality goods.